Okay, and on we go with question 7 of this paper 2. Land enclosed between a path and a railway line is being developed for housing. This land is represented by the shaded area shown in diagram 1. You have a path being represented by the parabola y equals 6x take x squared, and you have a railway line y equals 2x, and 1 square unit of the diagram represents 300 square metres of land. And as you probably guessed, calculate the area of the land being developed. So what we're going to do here is we're going to get the area underneath the curve between whatever this x value is and that, and we're going to take away the area underneath the railway line at y equals 2x. Okay, so there we have it there. Now I've obviously done a few more numbers on this diagram. Why is that 4? And here we have the area, the shaded area we have to get. Let's talk about that later, and we'll talk about that number 2 later on. Why is that there? Okay, we need to get where the parabola and the line cross. So I've set them equal to each other. So your y equals 2x was the railway line, and there's a parabola. Why have I done it this way? Because if I move that over, you get plus x squared, which is the way I prefer to solve my equations. That 6x becomes minus 6x. Tidy them up, you've got x squared goes to the front normally. 2x take 6x is minus 4x. Factorise it, common factor, x times x take 4. So this gives you 0 and 4. So the line and the parabola meet at 0 and 4. So we now need to get the integral between 4 and 0 of parabola take away line. So here we have it here. 4 to 0 of, there's the parabola, y equals 6x take x squared. Take away the line, y equals 2x. And there we have it there. So we integrate between 4 and 0. 4x take x squared. So we normally move to the great big brackets there, upper and lower limits. Integrate 4x, you get 2x squared. Any doubt about that? Just differentiate that. 2 times 2 is 4. 4x, yeah, that's okay. Integrate minus x squared, you get minus a third x cubed. Again, you can always differentiate. 3 times a third is 1x squared, yeah, that's okay. Putting in 4 is really quite easy. You substitute x for 4 in the diagram, so it's 2 times 4 squared, take away a third times 4 cubed. Calculator makes that very easy. 10 and 2/3. 0 of course gives you 0 there. So the area is 10 and 2/3 square units, and don't forget that each one stands for 300 square metres. So the area of land is 3,200 square metres. Okay. Now, just going back to part B then, here we have it here. It's decided that the land represented by the shaded area in diagram 2. Now what's all this about? Okay, a road is to be built parallel to the railway. Parallel means it's got a gradient of 2, same as the railway, and it's a tangent, so it briefly touches the parabola there, and there's the shaded area. So we need to get the area of this bit here. So we're going to get the area underneath the line, which we're going to have to find, and take away the area underneath the curve between that value and that value. Okay. So of course earlier on I gave the game away by telling you that that was 2. Okay, and again there's the shaded area in the diagram that I did. Okay, why is that 2? Here we go. So remember we need to find the point on the curve that's got a gradient of 2 because it was parallel to the railway line. So we have y equals 6x take x squared is the equation of the parabola. Differentiate that and you get 6 take 2x. Now that of course is a formula for the gradient of the parabola at any x point along it. We want to know when it's equal to 2, so this is quite simple. Okay, 6 take 2x is 2. 6 take away what gives 2? Of course 2x has to be 4. 6 take 4 gives 2. 2x gives 4, so x is 2. Now we need to get the point of contact of the parabola. So when x is 2, y is 8. Why is it 8? Well, of course, you just put it through the equation of the curve. Y is 6, 2's take 2 squared, 12 take 4 gives you 8. So the tangent meets the curve at 2, 8. So just go back to it. So we have a line going through 2, 8 with a gradient of 2. So what's this equation? Y minus b is mx minus a. Y minus 8 is m2x minus 2. Multiply it all out and minus 8 becomes plus 8. So you end up with y equals 2x plus 4. So the equation of this line here is y equals 2x plus 4. And then you have the parabola 6x take x squared. Okay, so the area of the car park is found using the following integral. We're going to integrate from 2 to 0, that's the x coordinate of the point of contact. There's the equation of the road. Take away, now this time it has to be in a bracket because it's got two things there. Tidy it up a bit, 2x plus 4, take away 6x, and take away is a plus x squared. A wee bit of tidying up here. Again, the x squared comes up to the front. So you're integrating between 2 and 0, x squared, take 4x, that's your 2x, take 6x, take 4x, and you've got plus 4. Okay, and we go on to integrate, and we've done the integrated x squared already. Take 2x squared plus 4x, so that's what you get when you integrate that there. You put 2 through it. Again, simple with your calculator, and you put 0 through it. Obviously you get 0. So you get 2 2/3 square units if you get that. Don't forget to times it by 300 square meters. So the area of the car park is 800 square meters.